Cool. Today we're going to compare the operators we've seen in the last 4 videos. In particular, we're going to take a look at function application, Fmap, sequential application, and bind. Let's do it. Okay, let's recap the 4 operators we're dealing with. So in a previous video, we talked about the function application operator. And we also said that its implementation is kind of simple. It takes its second argument and applies it to the step function, which is its first argument, to generate the output B, which is what we need. In a subsequent video, we covered Fmap, which introduces the idea of a context. In this case, a functor. So we have a value of type A wrapped in a context F. And the idea is that somehow this value of type A is unwrapped out of the context, applied to this function here to generate the output B, which is then wrapped again in the same context F to generate exactly what we need. Now, what we also said is that this context F works as a discriminator, meaning that depending on the semantics of the specific functor we're dealing with, the step function is applied in a different way. Then we move to the sequential application operator, which works similarly to Fmap, with the difference that we don't only have the context F here, we have a second F here too. Meaning that things work similarly, but the way this function here, the step function, is applied is now depending on not one, but 2 discriminators. Lastly, we took a look at monad and bind, where here we are in a similar situation as Fmap, where we have one discriminator and one discriminator only that decides how this step function is applied. But differently from the previous ones, the step function in monad not only decides on how the A evolves into the B, it also can decide and decides on the value constructor of the specific monad that is being used. Let's take a look at an example. So let's use iter, and remember that we use this data type whenever we want to run a computation that could either succeed, returning a value of type B, or fail with an error of type A. Okay, so we will be using show as a function for our example, which is what we use in Haskell to turn pretty much anything into a string. In terms of the function application operator, nothing strange happens. Actually, we could have omitted the $sign and this would have worked the same. We are just applying this value here to the function show. With Fmap, things change quite a bit. So first of all, notice that on the right of the Fmap operator, we have an iter and not a value. So we have a value wrapped up in the iter context. And the semantics of iter dictate that we apply the function on the left only when on the right we have a right. So in the first case, we have a right of 1, so we apply 1 to show. We rewrap inside of right, and this is our output. In the second case, we have a left on the right. So that means we don't even bother running the show. We just short circuit and return left of string. With the sequential application operator, we have 2 discriminators instead of 1. So now we proceed with the same semantics as we have seen in Fmap, meaning that we apply the function only when we have both rights. Now, in the first case, we apply 1 to show because they're both wrapped in rights, and then we rewrap. In the second case, we have a left on the right, which means we short circuit and return that exact value. In the third case, we have left on the left, which means we short circuit and return this. Notice that in the fourth case we have a type error, and that's because iter is a context which accepts two types. As we have seen before, it's either of A and B. But functor is a context that is supposed to be wrapping only one type. So essentially, we are dealing with the functor being either of A, which means that that A must be of the same type. In this case, we have an A being a function and an A being a string, which of course doesn't type check. Lastly, we have monad, where we have only one discriminator. So we apply the step function whenever we have a write. So in the first case, we have a write of 1, which means we go on and apply the step function, which returns to us write of 1. In the second case, we have a left, which means we short circuit and directly return that value. In the third case, we have a write again, so we go on and apply the step function, which gives us back a left. And in the fourth case, we have a left, so this short circuits again, and we don't bother applying the step function. Notice that in this case, the step function can change the value constructor that we return. For example, in the first case, we started with a write and we ended with a write. But this is not true, for example, of this third case here, where we started with a write and the step function decided to return a left. And this is what is different when it comes to monad. And those were the 4 operators side by side. Please feel free to hit me with any feedback you have. I'll see you next time.